So this is problem 6 of the AIME. Define an ordered quadruple A, B, C, D as interesting if 1 is less than or equal to A is less than B is less than C is less than D is less than or equal to 10, and A plus D is greater than B plus C. How many interesting ordered quadruples are there? First, let's determine how many different quadruples are there. So basically, if you pick 4 distinct numbers between 1 and 10, then the order, then A, B, C, and D are all determined because they're in numerical order. So we have to find the number of ways to choose 4 numbers from 10 numbers, which is of course just 10 choose 4, which is equal to 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. So then, and then this multiplies to 210. So there are 210 ways to pick the numbers. So if we rearrange the inequality, we get A minus B is greater than C minus D. Now, by symmetry, there are just as many cases where this happens as there are cases where C minus D is greater than A minus B. So what we can do is figure out how many times A minus B equals C minus D, or perhaps more easily when D minus C equals A minus B. And then the answer we want would be 210 minus n over 2. So to determine that, let's say that A minus B, obviously A minus B can't be 0 because these are distinct numbers. So let's assume that A minus, or rather that D minus C equals 1 and A minus B equals 1. So if this is the case, then we only have to specify what A and C are to find out what all 4 numbers are. So let's draw a table. If A equals 1, then that means that B is B is 2, so that means C must be at least 3, but since D can be no greater than 10, C can only be up to 9, so C can be any number from 3 to 9, so that is 7 numbers. If A equals 2, then by a similar argument, C can be anywhere from 4 to 9, so that's 6 numbers. If A equals 3, there are 5 numbers, etc. If you continue this, you basically add the numbers from 1 to 7, and if you do that, you get 28. Let me extend this. Now, let's assume that the differences of these are both 2. So if A equals 1, then B equals 3, and C has to be at least 4, but still 9 or less. So this is of course 6. No. Yes. It can only go up to 8 because D can only be up to 10, and so then 10 minus 2 is 8. So then this is 5 numbers, and then if A equals 2, then C can go from 5 to 8. So then this is 4, and then you'll get 3, 2, 1, which adds up to 15. So if you say that the differences are 3, then if A equals 1, B equals 4, and C can only be between 5 and 7. If A equals 2, then C can be either 6 or 7. And if it equals 3, then C has to be 7. So that's a total of 6 possibilities. And finally, if the differences are 4, then A is 1, B is 5, C has to be 6, and D has to be 10, so that's 1. So then N is the sum of this, which is 29, 35, 50. So N equals 50. So then the answer we want is 210 minus 50 over 2, which is equal to 80, which is the answer.